Can you distill a life down to a single day? In the case of our buildings, you can and you absolutely should. Today, I'll be showing you how we can assess the life cycle carbon impacts of our very own projects in just one day, and more importantly, why all of us should be doing it. Whole life cycle carbon is the carbon emitted throughout the construction, use, maintenance, and demolition of a structure. Typically, this carbon burden is broken down into a number of stages. When it comes to assessing the carbon burden of a project, each of these stages requires a different set of parameters and a separate method of calculation. And as you can see, it gets really complicated quite quickly. Now, traditionally, carbon saving has been focused on this operating stage, things like lighting, air conditioning, and vertical transport. Carbon emitted by these activities is termed operational carbon. But the other stages, the production of the materials, the construction of a building, and its demolition, all make up a significant portion of a building's carbon cost. In fact, this carbon, what we know as embodied carbon, makes up around 28% of a typical new construction. And as grid decarbonisation continues across the globe, it's expected that embodied carbon emissions will make up about 40% of a structure's total emissions. This leaves embodied carbon as an area in which big sustainability wins can be made. We can see that this has entered the global conscience through recent events in the legislature surrounding embodied carbon. Currently, 11 nations, including Canada, the US, and the UK, as well as several in the EU, have standards that dictate the assessment of whole life cycle or embodied carbon. And Colorado just became the most recent state to pass legislation more stringent than that of federal policy. Currently, the industry way of assessing embodied carbon goes a little something like this. We take a project, push all the way through to the detailed design stage, produce a Revit model for it, and then we put it through a program like One-Click LCA. In practice, this is what it looks like. This is Belmont Street. It's one of the London office projects, a 3-building residential block with a combined 22 stories of building and a gross internal area of 12,200 square meters, or 130,000 square feet in old money. Now, to get to this point, the point where we can accurately assess the embodied energy of a building, we've put in about 110 hours of modelling and a similar number of hours in engineering. And after we take it through the software and put it into the format that the Greater London Planning Authority requires, we get this, a 1990s style boy blue table that's about as useful as an engineer in a social situation. There are two really big problems with this process. Firstly, it's costly. By the time we're ready to do an assessment, we've spent around £1,000 or $1,400 US in modelling alone, and more than that in engineering, before we can even use the most popular piece of software on the market. And because of this, the process is entirely retroactive. The costs represent a massive barrier to design change. By the time we're able to assess how carbon heavy our building is, we're past the point where we as engineers can make a design difference. By this point, all we can really do to the structure of the building is measure its carbon cost. Any sustainability suggestions we make are really just greenwashing. Now, while this may sound a bit dire, all of these problems are really just opportunities, and we have the solution. I'm hoping that this looks very familiar to you. It should. It's the Belmont Street building, the 3-building, 12,200 square meter building I showed you earlier. Except it's not really. It's the first step in our new digital workflow for whole life cycle carbon assessment. What's modelled here is 4 hours worth of modelling performed by a grad with about an hour's worth of Revit instruction. The information modelled has been taken from a simple 2D massing plan provided by the architect. I cannot stress enough that this is the outline planning information. It's before a single number has been entered into a calculator. From this information, we've taken just a few arguments, the building use type, the area and the height of the building, and a few others, and we've created a tool through which you can start to compare how your design decisions might impact upon the construction's carbon emissions. In a matter of hours, we can compare things like framing material, floor sizes, and even architectural build-up. These factors can all be changed, assessed, and optimized before a single column has been sized. As engineers and architects, we can now draw a direct link between our design decisions and their sustainability outcomes. And from that assessment, we can start to create something like this. I'd like to take a moment and encourage you to take a look in the chat box. There should, technology permitting, be a link coming through now, which will give you access to this very report. If you're feeling daring, I'd encourage you to open the link up on your phone. These reports all come with a mobile compatible view and interactive features, So please, if you get the chance, open it up and have a play around. As you look around the report, you should notice that all of these reports have the same information as this. In fact, it even creates one of these old school assessments as part of the output. But we can do so much better than this. Through our new digital workflow, we can produce dynamic and interesting reports, and we can demonstrate to clients how our designs can reduce their carbon footprint and how their design decisions can drive the sustainability. In a sentence, it allows us to design with community in mind and encourages our clients to become a part of that community. And we can do all of this in a day, from massing report through to report in 7.5 hours. This previously was a process that took 3 days in the premier whole life cycle assessment software. Our innovative workflow has reinvented the process and transformed it to something that you can do in just a day. This is Pudding Mill Lane, and it's the first project that we developed the tool on. Pudding Mill Lane is a 17-building project beside the River Thames, and it's the reason this process exists. Stantec was appointed to provide engineering services, including a whole life cycle carbon assessment, across a range of disciplines at the master planning stage. Additionally, the clients had put together a sustainability statement that explicitly stated a 15% target for the reduction of embodied energy. Now, this project is much larger than Belmont Street, and to even begin structural design work on a site this scale would require an immense mobilization of resources. One can only imagine how many hours would have to be poured into the design and modeling of the 17 buildings on site before we could go through traditional software. Instead, we've synthesized the architect's model with our digital whole life cycle carbon workflow and created something fantastic. It's an interactive report that encompasses all 17 of the structures on site. With this report, we can take clients through structure by structure and demonstrate where they can make sustainability wins. We can show them just how much carbon they can save, and we can show them how it can be done. We'll show where in the life cycle of the structure, their savings are being made. In short, we've taken the boring and we've made it brilliant. Now, I know what you're thinking. This all sounds great, but how will I actually use it? These reports provide 2 distinct advantages to Stantec. We are both able to offer a new service and enhance our current ones. The most immediate impact will be this new service. This digital workflow adds an arrow to the quiver of Stantec engineers by allowing us to conduct whole life cycle assessments. It's particularly relevant in the UK at present, as the Greater London Authority has mandated these assessments be submitted with planning applications at both the outline planning stage and at the detailed planning stage. We already have several successfully completed projects that have used this workflow and several more in the pipeline. But this will doubtless have future relevance in the North American markets. As grid decarbonisation accelerates and embodied carbon comes more into focus, we'll see other states following the lead of Colorado and California in passing buy clean legislation. But perhaps more importantly, this innovation will begin to create an intuition in our engineers around embodied carbon and what efficient design for embodied carbon looks like. By conducting these assessments at a point in which we can still make changes, we can begin to create a language around sustainable building design. Through this language, we can more effectively communicate our ideas and fulfill our Stantec value by doing what is right.